So if it's okay, yeah, I'm gonna log off of my cell phone and
Okay.
log in so I can share my screen on my laptop.
Recording in progress.
Okay, you can't have it too because it's an echo.
Um, 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 Are you able to see my screen?
Okay, now I can see your screen, but
Okay.
it says launch meeting.
Oh, trying to minimize this top.
I'm seeing your entire laptop, Super Bowl, full of video.
Yeah.
Okay. So it costs $2,700 to manufacture 100 items. Okay. And 4,200 to manufacture 200 items. Okay. So this is the typical question that allows you to, that requires you, or from which you can develop an equation. Okay. Now,
Mhm.
remember when we are talking here about linear functions. Okay. So some value, one value, the dependent variable value depends on the independent variable value, right?
Right.
And so, why we talk about linear functions is that, excuse me,
That's
when we say linear function, so we're simply saying that the relationship between the dependent and the independent variable is a straight line. Okay?
Mm-hmm.
That's what we're saying that we call it linear function. So the relationship is a straight line. That is when you plot it on a graph, or the relationship, the rate of change is constant. So when you draw a straight line, you see that the rate of change is constant. For example, if you drive for 10 miles, okay? Yeah, if you drive 10 miles, your gasoline is going to decrease by 1/4 of a gallon. Okay. If you drive 11 miles, your gasoline is going to decrease by another 1/4 of a gallon. And so every 10 miles that you drive, your gasoline is going to decrease by 1/4 of a gallon. All right. Okay. So
Mm-hmm.
if you drive at 40 miles per hour, the rate of change is 40. Because if you drive 1 hour, you drive 40 miles. If you drive 2 hours, you drive 80. So the difference between 80 and 40 is 40. If you drive 3 hours, you drive 120 miles. So in that case, again, the rate of change is constant. So this is what we call a linear function. Right.
Right.
So in this case, you say you have issues with uh, which variable is the dependent variable and which variable is the independent variable. So in this case, the dependent variable generally we call y, and the independent variable we call x, but it can be anything, okay? It can be
Mhm.
c and m, things like that.
Right.
So now for this particular problem, let's look at it, all right? We are saying here, what causes what? What is it that depends on the other?
So depending on the items, the
Depending on the
cost
number
changes.
of items,
Yeah, depending on the number of items, the cost changes.
precisely. So the dependent variable here is the cost,
Right.
because you choose the number of items you want to produce. And once you choose the number of items you want to produce, you do not control what the cost can be. The cost is going to be, dependent on nature. Okay.
Right.
So,
Mm.
so in this case, your Y will be the cost. Okay.
Right.
All right. So now what it says is if you manufacture 100 items, it will cost you 2,700. If you manufacture 200 items, it will cost you 4,200. So the first cost is 2,700. So that is what you call Y1. The second cost is 4,200. That's what you call Y2. All right? Okay. So the first thing that you do here is you find the slope. And, and that's here, in this case, the slope represents the unit cost of production, the cost of the cost of production per unit, which is, for example, if you manufacture 10, uh, if you manufacture 10, your cost could be 50. If you manufacture 11, your cost is 55. So the change for each additional unit is 5. If you manufacture 12, your cost will be 60. So your unit cost is 5 because
Right.
each one costs you 5. Now, but there's something called a fixed cost. So in this case, we find the slope first. We find the unit cost first. So we go y2 minus y1 over x2 minus x1. So you find the slope. So I'm going to write this down, and then I'm going to do it. 2,700 and 100 for 200 and 200. Okay. So let's see. So you should unshare. Okay. You should stop share.
Okay.
We have the, okay, let's see if I can pull up the whiteboard. They have whiteboard here. Okay, I see one. Right. So here, so 100 units. You have to be patient.
Mhm.
So this is units. Yeah. Then the cost. So this is 2,700.
Right. And that's what I put. I put 100x plus 2,700.
But that's not how to go about it. So this is what I'm trying to,
Oh, gotcha. Okay.
yeah. You manufacture 200 units,
Mm-hmm.
it will cost you 4,200. All right. So like I said, cost depends on how many units. Am I correct?
Yes.
Okay. So this is Y, and this is X, the number of units produced. So this is Y1, and this is Y2. This is X1, and this is X2. You get it?
Yeah.
Okay. So you have to create an equation of this model. Okay. So you have to create an equation of this model. Now, a linear function is like that. Because linear function is like that. It's a
Right.
straight line. So y x. So
Mm-hmm.
this straight line is called y is equal to f of x.
Mm-hmm.
And it represents a constant value, which begins here, and then a rate of change. For example, y is equal to 10 plus 2x. Do you remember that?
Yeah.
Good. So in a linear function, you can see 2 is the rate of change. 2 is the rate of change, but you begin from 10 here. This starting point is your 10. Then this slope goes up at the rate of 2 for each additional unit. For each additional, this is 1. This is 2. So in that case, now since y is equal to 10 plus 2x, you begin from 10. And so when x is 1, y becomes 10 plus 2 times 1. So when x is 1, okay, here, what will y be? What is 2 times 1?
2.
2. 2 plus 10 is what?
You said 2 plus 10?
Yes,
12.
very good. So here y will be 12. When x is 2, what is y?
It will be 14.
It will be 14. You can see the difference is 2. Is that correct?
Right.
Okay, so we have a constant rate of change. So this is why we call it a linear function. The rate of change is constant. It's for this linear function. So we have then what we, in general, we say y is equal to a plus b times x in general. So in that case, here for this function, y is equal to 10 plus 2x, a is 10
Right.
and b is 2. Is it making sense?
Yeah.
Okay. So, so B represents the rate of change. If B is 5, then the value of Y will change by 5 every time the value of X changes by 1. All right?
Yes.
Now, I'm going to erase that. I'm going to erase this. All right. Now, the function could be downward sloping. Y is equal to, say, 30 minus 3x. Now, in this case, the rate of change is minus 3. And so what you would have will be like here, 30. This is the beginning point, and it goes that way. So this is y, and that is x. So you can see here, because the sign of B is negative, you have a downward sloping curve, okay,
Right.
downward sloping line. So this is a negative relationship, all right? So when x is 1, y is 30 minus 3 times 1, which is 27, when x is 1, okay? When x is 2, y is 30 minus 3 times 2, which is 30 minus 6. And so we have 24.
Right.
Is it? So y is always decreasing by 3 each time x increases by 1. If x decreases by 1, then y will increase by 3.
Right.
So we call it a linear function. The rate of change is constant. It doesn't change, okay? All
Yeah.
right. So now what you are encountering is how do you then create this equation when you have numbers? How do you find B? How do you find A? So what we then do is we have y2. So the slope that is this B, this is called the slope
Mm-hmm.
or the rate of change, right? That is called the slope or the rate of change. Right? This
Right.
B is the slope. A is the constant value, the starting value. You get it?
Mm-hmm.
Okay. So when we have numbers like we have here, we ask ourselves, how do you get A? How do you get B?
Well, A would be the Y and B would be the
No,
X.
no. A will be the constant value. The Y's are the 2,700 and the 4,200. The X's are the 100 and the 200. This is the dependent variable, right?
Mm-hmm.
The dependent variable because the cost depends on how many you produce. Am I correct?
Right.
Good. So we start by calculating the slope. Y2 minus Y1 divided by X2 minus X1 is equal to B, equal to the slope. You get it?
Yes. Okay.
So you get that one first. Once you get it, then you can find A. And this is what we're going to do. So in that case, we have 4,200
Minus 27.
minus 2,700. I'm
Mm.
going to say B equal to that. So we're dealing with 4,200. I said we have to be patient because of the pen.
Mhm.
Minus 2,700
Mm-hmm.
over 200 minus 100. We correct?
Yes.
Okay. And so now 4,200 minus 2,700 is 1,500. Am I correct?
Yes.
Divided by
100,
100.
which gives you 15.
So B is equal to 15. So this rate of change is 15, and that is your unit cost. Because each time you increase the units, the number you produce by 1, then the cost will increase by 15. You get it?
Understood. Yes.
Okay, because essentially what you have said here is when I went from 2,700 to 4,200, so I subtract 42, I'm sorry, I subtract 27 from 4,200. So when I
Right.
went from 4,200 to 2,700, my cost increased by 1,500. Is that correct?
Right.
Okay. The number of units I could produce increased by 100.
Mm-hmm.
Therefore, it means that each additional one I produce costs me an additional 15.
Right.
You see how it's making sense?
Yeah.
Okay. So now let us find A. Because we are beginning from the idea that Y is equal to A plus B times X. All
Right.
right, that is what we're beginning from.
Mm-hmm.
Okay. And we found B by taking y2 minus y1 divided by x2 minus x1 when I produce 27 when I produce 100 it cost me 2,700. Now when
Mm-hmm.
I start to produce 200 it cost me 4,200, and therefore my unit cost must be such that the additional 100 cost me an additional 1,500, and so the cost of each additional one must be 15.
Right.
Get it? Okay, how did we get this B? So we say Y minus 2,700 over X minus 100 is equal to 15. Essentially, what you're saying is, okay, whatever Y was when I subtracted from 2,700, and whatever X was when I subtracted from 100, excuse me, whatever Y was when I subtract 2,700 and whatever X was when I subtract 100, I get 15. So
Mm-hmm.
therefore, what then is the relationship that I can create out of this? So then you go here, Y minus 2,700 must be equal to, now you're going to take this whole equation from below to the right-hand side of the equation. Do you remember that process?
I do, but
Okay, but so now you take what's at the bottom and take it up. What's at the bottom. So when you take it to the right side, then you multiply it. Am I correct?
mm-hmm.
Good. So with 15 times x minus 100.
And Professor, you could have used either one, right? So
Um,
we could have used the 4,200 as well.
okay. Now, if you use the 4,200, what you will do is you say 4,200 minus y. One side must be a general thing.
Okay.
You would have said 4,200 minus y is equal to 200 minus x. You get the
Mm-hmm.
same answer.
Okay.
Okay?
Mm-hmm.
Okay. All right. So then when you say y minus 2700 is equal to 15 times x is what?
15x.
15x.
And then you get
And 15
minus
times 100 is what?
uh 1500.
1500.
What is negative 1500?
Negative 1500. All right. So now we have y minus 2700 is equal to 15x minus 1500.
Mm-hmm.
And so now you're going to take y, you're going to take x, I'm sorry, you're going to take 2700 on both sides. So, I mean, if you add 2700 here, your normal algebra thing,
Yeah, that cancels out.
that cancels out,
And then you
is
have
equal to
um,
plus
1300.
2700. Here it's more like 1002.
Oh, this is
So
15.
then, so this cancels out. So then we have y is equal to 1200 plus, since there's no sign here, so that means it's a plus,
Mm-hmm.
15,
15x.
15x. So the rate of change is 15. The
Right.
fixed cost of production is 1200, which is the constant value. Okay.
Mm-hmm.
It's like, let us say that you rent you rent a place to do business, and your
Mm-hmm.
rent is 1,500 a month. Is that correct?
Right.
Okay. So whether or not you sell anything, whether or not you produce anything, you must pay your that fixed rent. But then if you are producing with other materials, then the more you produce, the higher your cost, your expenditure for the month. You get the idea?
Yeah.
Okay. It's like you go to rent a car. You rent a car for $100 a day. Whether or not you drive it 1 mile doesn't matter. But but for each additional mile you drive, the rental company will charge you 25 cents or 15 cents. So your rate of change is 15 cents. You get
Okay.
it?
Yeah.
Okay. All right. So this is the question that they're asking you. So here your unit cost is 15. Your fixed cost is 1200. Is that
Mm-hmm.
clear?
Yeah.
All right. So, I mean, the start of our problem is that, first of all, you needed to understand which one is your y and which one is your x. So you should just think about what is causing what, okay? Is the number of units that cause your cost to increase. You get the idea?
Yeah.
Okay. Any other question?
So, okay. Um, so most of the questions for this topic is pretty much using that same
Yes. All of
method.
them are using this. All you have to do is now to think about what is causing what, which one you call your y, which one you call your x.
Okay.
They may be talking about different things. Like here, they're talking about, production or manufacturing.
Right.
So they could be talking about, say, your electricity bill, the way I was talking about it. They could be talking about renting space and then selling whatever you sell, so forth and so on.
Right. Okay. So just basically it's just understanding like what's the slope called what's the slope and
Yeah, what is the dependent variable and what is the independent variables? What is causing what? That is that is
mm,
the key thing that you need to look at for. Like here, we say that it's the number of units that increase our cost.
okay. All right, so I'm gonna definitely apply that method to the rest of them, see if I could.
And if you have any questions, just send me an email.
Okay,
Okay?
definitely.
I could just arrange a quick Zoom session with you and then we work on it.
Okay.
All right?
Yes, thank you so much.
All right. So, any other question?
Nope.
Okay. All right. Have a nice evening. Thanks for seeing you.
Thank you, same.
All right. Bye.
Bye.